let's try this one. Okay, x squared plus x plus y squared plus y to the 4/3 equals 2. Okay? Now, in the last problem, in part A, you could have gotten y by itself. We've solved that for y in the past. Like on test 7, we solved that for y, actually. We did semicircles. So you could solve that one for y. Now look at this one. The y has a squared, and another y has a 4/3. Imagine trying to get y by itself in this problem. Okay? Very difficult. There are some that you'll learn in college if you go far enough through mathematics classes where you can actually get y by itself, but it's awful. Okay? So, for some of you in high school, there's no way we're going to get that y by itself. Don't worry about it. Okay? It can be done, not worth it. So instead of solving for y, couldn't we just do an implicit derivative right now? Okay? When y is hard to get by itself, do it implicit. Okay? Because it will always work. So, what is the derivative of x squared?
2x.
2x. What is the derivative of x? 1. Now, the derivative of y squared is 2y to the first, and the chain rule of the base
Y prime.
is y prime instead of 1. That's the big difference today. Okay, does that make sense? All right, how would you take the derivative of y to the 4/3?
3 1/4.
4/3 to the front. Base always stays the same.
1/3.
New power is 1/3. Very good. And the chain rule of the base y is y prime again. All right, so the derivative of x is 1, but the derivative of y is y prime. All right, and the derivative of 2 is 0. Okay, this is a very helpful method because there are certain cases where you want to do the implicit derivative, you do not want to do the other way. Okay, so this really helps us with unusual functions. All right, matter of fact, you can see what the graph of this function looks like. Kind of looks like it's a semicircle, but you see how they actually have jagged corners there?
Yeah.
Like a sharp corner, and kind of a little rise, and then it comes down again. And notice I didn't put arrows here or here. If you don't put arrows in math, that means dead end, is what that means. So it just stops. So in other words, of all the xy combinations that can actually work in this function, there are no xy combinations past this point that would work in this equation and make it equal to. And there are none over here either, so it stops, dead end.
Where would the coordinate plane be out then?
What's that?
Where would the coordinate plane?
Well, it's like, okay, let me draw the axes here so you can see this a little better. So it's kind of like this. It's almost like a semicircle, but sharp right there in the corners. Okay? And so beyond that, there's nothing that works. Okay? Try to put like 7. No y that matches it. All right. You want me to?
No, just finish problem.
Okay. All right. They're cueing me to roll on here. Okay. Here's another way to write this, by the way. Y prime. Do you remember the fancy notation for y prime?
F inverse x.
It is d y
Over dx.
over dx. So actually, this can be written this way. Now, most of you probably won't choose this because, as you notice, it's a little bit more writing. Okay? It's the same thing. It's identical. We'll do a couple of problems in calculus, though, next year where you can't solve it unless you write it as dy dx instead of y prime. Usually, you can just do y prime 99% of the time. Okay? I'll show you a few next year where you have to write it dy dx. So just kind of keep that in mind, that we are doing the derivative of y, but with respect to x. That's what that means. Okay? The x's are normal, the y's are the y primes. Okay? All right. So let's do this. We've done the calculus, we've done the pre-calculus. We are just trying to do the algebra 1 now. Okay? So you got the pre-cal step done. By algebra 1, how would you get the y prime by itself? Okay, I see one here and one there. Okay, what would you move first? Okay. Oh, look at this. Okay, the y prime buddies want to be with themselves. These aren't y prime buddies, so put them over there with the not so y prime buddies. So why don't we subtract this from both sides and put it over there? Okay. Again, it's really just algebra 1. Now, it's kind of extreme for algebra 1, but it's really just the same concept. Do the opposite of both sides. That's all we're doing. Okay? And I'm trying to get this y prime by itself. We did one kind of like this on the August review sheet. What do you need to know for pre-calculus? Even if in middle school you had never heard of y prime and didn't know what it was, you could still isolate it and get it by itself. I've got 2 of them. how do I get two of those to become isolated into one?
Oh, the distributive factor.
If you,
Opposite.
yep, it's like reverse distributive, yep, factor it out. Couldn't you just factor it out? What if we factor out y prime? Oh, look at this, it's isolating itself. How about that? Okay. Looks a little complicated, but it's all Algebra 1 based. Can you isolate something? Okay? In Algebra 1, they even gave you those problems like AB plus CD equals E, and you had to isolate D or isolate C or whatever it was. It's trying to get one thing by itself. Okay? And right here, you almost have it by itself, but it's doing multiplication next to the parentheses, so we have to divide both sides by all that stuff. And there it goes. And you now have y prime by itself. Okay. And you get some kind of crazy answers here. Of course, these are crazy curves here. These are not nice little parabolas, hyperbolas. Okay? Very unusual curves. And so you get these wild-looking derivatives. Now, there is one small problem with that answer right there. You can't leave a what? Fraction in a fraction. Right? Okay? There's a little fraction, there's a big fraction. What I really want to do is get rid of that third right there. Now, the hard way to do it, you could make that 2 into a 6/3 and do a common denominator. You can do it that way. I think here's the easier way. What do I want to get rid of? The 3. You know how to get rid of it? I can send a 3 through there by the distributive property. Wouldn't that knock it out? But wait, you can't just invent a new problem on the test. Mr. Wade, I don't like your problem, I'll just make it 2 plus 2. Well, okay, it has to be mathematically legal, right? If you multiply 3 on the bottom,
3 on top.
you must also multiply 3 on the top, and if you also multiply the 3 on the top, guess what? You can get away with it. It's fine. So pick the denominator that you want to destroy, or set aside.
Is this like Minkowski?
No. I didn't hear about that.
Numbers and
Okay,
units.
I want that 3 to leave, all right? And so I'm going to put the 3 through there to knock it out. So your final answer would be y prime equals, all right, what's 3 times negative 2x? Negative 6x. What is 3 times negative 1? Negative 3. What's 3 times 2y? 6y. What's 3 times that 4/3? 4. Why the 1/3?
For the exponential or the radical?
That's probably better. Now it started an exponential, so you probably want to leave it an exponential. I wouldn't count off if you make it the 3rd root. But since it's gonna start